Next piece in line. This is the main frame casting. This is going to be fun. Very clean casting. Everything looks to be fairly well aligned. A little mismatch, but I don't think that's going to hurt anything. And naturally, like everything else, we start here. Going to clean it up. All the flash lines, all the parting lines, they got to go away. And then we'll figure out where to start this part. And according to the print, whenever you look at a print like this on a casting, pay attention to where all the dimensions are coming from, and chances are that's the datum that they're looking to convey to you is the most important. So that would be this boss right here. So once this thing is all straightened, cleaned up, not straightened out, not yet, I may take a couple of superficial cuts on here to establish banking surfaces, and then I can figure out what goes where and start from there. So I'm going to grab a file, make this thing pretty, blast it so it looks like it cast it. How's that sound, huh? Blast it, look like it cast it. And then we'll come back and take a look at what the next step is. Break out the files. Here we go. And you know, as insignificant as files may be, it's nice to have them organized if you can. Let's turn the light out. Oh, that doesn't help, does it? Okay, this is just a wooden Eagle machine, Arlington, Texas. Great guys, phenomenal machinery. It's just a little wooden riser that I made for in between my 3 toolboxes here, and here's how I have my files set up. Brand new in the box, ready to go, never been used. Coarse, grab it, file it down, throw it back in. These are finishing files. Extremely sharp, extremely clean. These are round files, and these are needle files. So at any given time, if I want to grab, and the needle files are separated into, see the black band on there? That just tells me that this tube contains files with round features. Could be a round surface, could be a round edge, could be round, completely round. And this one without any markings is the square, rectangular, flat profile. So that's what I do there. And of course up here in the top of my box, I have the ones that Stan sent me, and thank you for that, Stan. Okay, now we can file them. Just thought you might like to see that. Let's give it a blast, see what it looks like when it's done. Still a very small remnant of the parting line right there. I might just have to refile that, knock that out of there. Everything else came out real well. I know this is a machine surface right here, so I didn't get crazy on that. Did not do the bottoms, faces, or the top. That's all machined as well. But I did manage to get underneath everything, get the lines out. Overall, a little different than what I started with. Getting closer to doing some machine work. I'm very pleased with this so far. So let me sleep on that line right there. And maybe we'll just put this in the mill and have at it. But I got to establish some gripping surfaces first. That's next. Alright, I slept on it, decided not to put up with that little dig in the bottom, and there was an inclusion in the top. They had to go. Next step is to measure this thing, figure out what square to what's parallel to what, and exactly where to start for the first cuts for clamping surfaces. That's first. After giving this some thought, made up a couple of nests for the sides. And they're not pretty, but it doesn't have to be. Just lay your material up there and start striking lines all over it and see where everything is. And it'll allow you to make a little nest that sits right on the side. I'm going to use the undersides of these as my banking surfaces because that's got to start somewhere, right? And same thing for the other side. And it is parallel enough that a piece of paper, or even not, should take care of this. Got the edges radiused to get in here so it doesn't fall short. And I think the first surface that I will attack will be this front one right here. And just stand it up in the vise like that. Take a dust cut on that. That'll give me something here I can register and start from there. All right, take it over to the mill, make some chips. I've switched over to some taller jaws for this operation, and I think that the part probably warrants it. Now keep in mind these are cleanup cuts only. They serve no dimensional purpose other than to assist in clamping down the line. I think that you can see the benefit to the nests. They hold it and locate it right where I want it to be located. And I'm going to take a fly cut pass across this top surface here to make that happen. Then I'll rotate the part towards me 90 degrees using a square against the surface that I just established and do the bottom. And we'll figure out how to do this surface last. But at least I'll have a parallel surface down here to register from. So I'll stand it back up. Just cut this off. See if that works. Here we go. Alright, that's a success on surface 1. This is considerably thicker than it needs to be for the final product, but I need something square to bank on and measure to. So let's flip the part, do one of the other faces. For sake of convenience, let's do the bottom. Bottom surface complete. Let's flip this part 180 degrees, maintaining this side against the stationary jaw. Register on the parallel right here, cut the top. Change the cutter, tweak the setup just a little bit, and we're going to take a reference cut off of each of these back faces. That will give me a reference to rotate the part when I flip it and clamp against this face. So instead of just assuming that it's square or having nothing to look at, I'll establish this face here and in the back right now. This is not to size, this is strictly for location. All the surfaces are square to each other. And now that I have tracking surfaces on either side, once I put it in the vise and squeeze it end to end, I can relate it this way, which means any features will then be square to the face. So think ahead, guys. Make sure that you really evaluate how the print's done. Now, I want to do these bosses on the side. I want to do all the features, all the holes, everything on the side, and hopefully I was praying that nothing was related to the center line of the part. And there is nothing related to the center line of the part. It's all relative from the surface to be machined to the side of the casting, and that works out really well. That being said, since all the dimensions on this side are given from the center of this hole, once I know what size end mill I will ultimately put in here, I can offset that end mill accordingly, walk it up, and remove material on this edge. Almost to spec, and the same thing for this edge here. Leaving a thousandth or two of material remaining. That way when I rotate the part and I shift it into a vertical format and I cannot reach that, if I cannot reach that, I will know that the witness surface that I created here is my oops, don't go any further spot. So with that said, I'm going to shift back probably to the smaller jaws because I just like the integrity of a shorter jaw. We'll set this up on a parallel across the back, mill these surfaces off, put all the holes in, and this will start looking like something. So far, so good. These little pads, they came in real handy. This is the setup I'll be using to do all the features on the side, and after I picked up on my boss right here, double checking my center, I put an edge finder in my drill chuck and moved over just to see how much material I have to take off of this face back here. Lo and behold, I need to put the metal back on tool in order to put something back on that face, because that face is about 16 thousandths of an inch under what it needs to be according to the print. Now, if you watch the cleanup cut on that top surface, that was absolutely a superficial cut, and I can't imagine 16 thousandths more into that. Anyway, it's not a big deal. The mechanism that connects from this boss to the slider arm going across the top is held on with like a chain link, and it will just cause that chain link to be in a different position. This is not a showstopper, but it is something that I will need to make notes of on the print. Heights given to the main casting. I'm going to drill the holes first, and that'll be easier to figure out exactly what I got. Let's do that. If you have any doubt whatsoever about the alignment of the hole to the boss, drill the hole undersized as I just did. This is a 360 drill. The 375 is a finished dimension. And I'm going to check the distance from the hole wall to the casting with a pair of calipers right now. See what we come up with. If you don't have an identical reading in all 4 points, then make your shift and finish the hole with an end mill or a boring bar. Like it. $199, 200, 200 all the way around. Close enough. I'm going to leave it right where it is. Finish the hole, finish the bolt pattern. I'm going to bore this hole, and I'm going to start checking the hole with a pin that's 5 thousandths under the size that I'm shooting for. When this pin does not enter that hole, that tells me that I can easily add another 5 to the next cut without worry of ruining the hole. Okay, that's a good quickie way to sneak up on a hole. 5 at a time. Once the pin that's 5 thousandths under goes in, you know that 5 thousandth cut on the next one is not suggested. That's when I break out the extra pins or the mating piece that goes in there for fit. And because most pins look exactly the same when they're this size, I write on the end. So this is 373, 374, 375. I want this one to go in just ever so snug. The height of this boss is called out as 125 from this surface to the top. Now that's going to be very hard to measure, so I'm going to show you a comparative measurement technique that I use that you may find handy. I'm going to put a gauge block right on top of that to the height that is required on the print. I've got my indicator zeroed on top of that boss. I'm just going to move over to the gauge block and look for the difference on the dial. Make sure that your needle is positioned accordingly per your manufacturer of your indicator so you don't get a cosine error. But I think I'm within the 10-12 degrees that it calls out for here. Everything is good. When you move the indicator around, be careful not to crash your tool into any other part of the component you're working on. Alright, we're about 5.5 away. I'll bring the table up 5.5, and that will give me my correct registration datum for all the other pads. Let's do it. With the part still in its correct orientation, it is time to drill and tap all the holes that are accessible from this profile, presentation, setup, whatever you want to call it. These are 172 holes. This is about almost a 2mm diameter screw. And all the holes that you'll see me drill and ream are 126 diameter imperial. That's about 3mm, 3.2mm metric for the rest of the world. Not just you guys in the UK. Although you're quite a presence on my channel, so thank you very much for showing up. I am extremely pleased with the alignment of all the holes dimensionally and cosmetically to the bosses on this side of this particular casting. Now, if there's any mismatch in the original casting, you're going to see it on the opposite side. So if you're ever inspecting a model like this, you'll be able to tell which side the part was machined from just by looking at the concentricity of the holes versus the cast features. This is the primary side. The side that's down facing the parallels is the secondary side and currently uncontrollable. Be interesting to see what it looks like when I flip it over. The final procedure on this side is to take a cutter of a known diameter, starting at the center hole here where all the dimensions are given from, and move over and put a dust face right here. Just take a gentle cut right there, bringing it almost to the spec on the print. Now this will help when you rotate the part vertically and you can't measure from here to that hole for one reason or another. You have a witness surface that tells you you have achieved your dimension. I'm going to leave mine about 5 thousandths higher than the dimension on the print. That way when I make contact, I know I'll be within the plus or minus 5 for the decimal tolerance noted, and I can go an additional 5 and still clean up. make sure that you have enough material to clean this up as well to the required thickness. Let's do it. And a simple pass like that is all it takes. If you watch my steam engine series, you saw me put a lot of reference cuts, and I tell you, they'll save your life at moments of real shock and awe. So let's take this part out, clean it up, test assemble some of this stuff, see if it works. This is what you can expect after that particular operation. Everything that can be done from this side was done from this side. Here's the small tracking cut that I took at the very end. Now when I stand it up, like I said, when I stand it up vertically, register off of one of the faces, I know that when my cutter hits this surface, I'm 5 away from the required dimension from this surface to that center. That could sometimes be a little tricky to do if you don't have the correct size pin or depth mics or whatever. So let the machine do the calculations for you. Glue it up, scuff it up, and then take another 5 and you're going to be right there. Part is nice and clean. And I gotta know if this is gonna come together, so bear with me for a second. I'm gonna throw some screws in this thing and put a part on there so you can see exactly what's going on. And at the suggestion of one of the comments, I spot faced the holes in this bracket arm. So whoever left that comment, thank you very much. I thought that was a great idea. This is the component that received the bushing. And I'll show you what this is for. Yeah, it's a little difficult to work around the camera here, guys. So if you see me fumbling a little bit, that's why. Now, although this is not the cone pulley that goes in here, this is the cone pulley area that when the machine is assembled, this will be your drive for the inside. I like it. Alignment's good. Everything is nice and tight. This particular hole down here where the crank arm goes on the inside. So as the gear that's ultimately connected in this area here will have a small boss on it, and as that gear goes around, that boss will translate to a reciprocal motion that drives the ram. I think we're going to call this one good for now and pick up with a part 2 for all of the other slots and holes that go on this component. Thank you for watching wherever you are in the world. I hope you're well and safe. This is Joe Pye at Advanced Innovations in Austin, Texas. I'm out.